Example 3 states, the distribution of ACT scores for high school students in a certain district is normally distributed with a mean of 21 and a standard deviation of 5. Use the 68, 95, 99.7 rule to determine the percentage of these students with scores between 16 and 31, below 11, and above 26. So one technique that you may find helpful whenever you are asked to use this 68, 95, 99.7 rule, you may just want to, even before looking at the numbers that are given in the question, is give a general idea of what's happening. So what's happening with this rule, if your mean is 21, that means the 21 is that center data value. And your standard deviation of 5, that means one standard deviation above would be 26. Two standard deviations above would be 31. I'm just adding 5. And 3 standard deviations above would be 36. One standard deviation below would be 16. 2 standard deviations below would be 11. And 3 standard deviations below would be 6. So notice the difference in all of those is 5 points. What's happening with this rule is that it's stating the percentage, one standard deviation above and below, 68% of the data is here. 2 standard deviations, 95% of the data is here. And 3 standard deviations, 99.7% of the data. Something else to mention is half the data is to the right, half the data is to the left of that 21. That's in the center there. 50% on the left, 50% on the right. So those are just things to keep in mind as you work through any of these, is having a general idea of what the rule actually is saying. So notice here in part A, it asks for the percentage of the students with scores between 16 and 31. So for that one, you're imagining 16 to 31. We have stated that there's a few ways you could do this. The way I would probably do it is look at it and split this up at the mean. Since within 2 standard deviations to the left and right is 95%, I would, for this right-hand portion here, because remember that was from 11 to 31. We're asking 1 standard deviation to the left, but 2 standard deviations to the right. So I'm going to go ahead and look at just the right-hand portion first. Take that 95 and split it in half, and that will tell me that 47.5% of the data is in that portion there. Then I can think of the 1 standard deviation idea, right? Within 1 standard deviation, that was the 16 to 26, that's 68%. So this portion here, 1 standard deviation to the left is half of that, 34%. And then you can add those percentages together. So from 16 to 31, you're going to have the 34% plus the 47.5%, which gives you 81.5% between those two scores. So when we look at part B and it's asking us for the percentage of students with scores below 11, we have the same picture. And even if we're not using all of these data points, it's nice to see them because you're getting an idea of 3 standard deviations to the right, 3 standard deviations to the left. This is a normal distribution. That peak should be at 21. That one was a little off. And your drawing doesn't have to be super accurate to get the right result. So below 11, we're looking at this data, this amount of data over here. So you have to kind of think of the big picture. The big picture is that under the entire curve is 100%. So we already know that this half over here would be 50. 50% over there. Now within 2 standard deviations, so you don't always go right to the answer. Sometimes you have to analyze the situation a little bit. So within 2 standard deviations, here to here, 11 to 31, I should have that 95%. If I want to know what is between 11 and 21 here, it's half of 95. So half of 95 is the 47.5. So here I'm figuring out the percentages everywhere else before I look for what's actually being asked for. So I know 50% is to the right of 21, 47.5 is between 11 and 21, and then since the whole thing is 100%, I can do some calculations here to get that desired value. So let's first add our 47.5% and our 50%. That'll get us 97.5%. And that represents everything from 11 over to the right. 97.5%. So if we want below the score of 11, we would do the 100%, which is everything, minus the 97.5%. So 2.5% is going, of the scores are going to be below that score of 11. Again, that's not the only way you could do this, but that is one way of getting that value. And lastly, we're asked for the percentage of students with a score above 26. Same scores. Mean is here, but we're going above 26, so that's 26 and to the right here. That's what we want to know. So once again, we already know this half is 50. We know within 1 standard deviation to the left and right is 68, so half of that is 34. So this one's similar to the part B, and we're actually calculating the part we're not interested in first, and then subtracting that total from 100. So if I do 50% plus 34%, I get 84%. And then since I'm looking for the part above 26, I would want to do 100 minus that 84%. So 16% of the scores should be above 26.